center of gravity of the rod from the center. I think we know, we are very sure, no? Where is the center of mass of the rod? If I don't discuss this problem, no, I think it'll be incomplete. That's what I feel. Let's get into the diagram. There is a you draw, you read question. Meanwhile, I'll adjust the diagram. Some small tunnel, hole is drilled, and inside that a rod is placed. That rod, I'll show it. Now the green color is a rod. Okay, there's a planet, there's a radius, there's a Earth. He's asking its center of gravity. What is the length of the rod? It is R, no? It should be R by 2. When it should be R by 2? Find the distance of center of gravity of the rod. Gravity is telling, not center of mass. Center of mass, where it will be? Center of mass will be at R by 2 only. Center of gravity, the effective weight, mg, like a through what point the weight will act. I think that's what the question that is being asked. So what to do now here? Means, what is center of gravity? The point through which the effective weight of an object will act. Then what is the basic formula? Again, the formula will be how to calculate the center of gravity. XCG is equal to that same idea of center of mass. I'll put it here. The effective weight. There it was dm. No, now dw will come. Integral of dw. In case of center of mass, xcm, we used to write like this, no? X into dm by total mass of the rod. So here what happens? The effective weight will come. The dw is what? Weight of the small element, and this is a total weight of the object. So dw is what? Weight. I think w are everything. W means weight. Center of gravity, center of mass need not be at same point. Can you remember? I think in the definitions I told you, when the size of object is comparable to size of the Earth, then center of mass, center of gravity need not be at same point. At that time, not much idea, no? I'm just to define that statement, to make you understand that statement, I brought a question here, no? Okay, let's get into that one. Let me assume a small element. See, in physics, everything is a numerical. There's nothing called like a concept that when everything, any statement what will end up with a numerical. Every statement what if you want to prove, you should take one example. It'll become a numerical. That's why if you say that, sir, I'm reading concepts, means what happen? I'll get a law of that one. Usually what's happen? So where is the concept? Everything is a numerical here. Okay, this is a dx. So weight of that will act here. So what is dw of this? Dw of this will be lambda into dx. So let lambda be the mass per unit length. Now let's get into the first dw. What is dw? Lambda into dx will be the mass. Now what is the acceleration due to gravity at a distance x? E should be equal to, what is the formula? gmx by r cube, gm by r square. What you can write? G, no? Because this will be better idea for us. So how you define dw, the mass of that. I'll get into the exact dw into E. There's a gravitational force, no? Or the effective weight. So dm is what? Lambda into dx. What is E? G into x. One r will be there, no?
Gx by r.
One r will be there. Yeah. Pretty sure. I think substitute that, integrate. What you should integrate? 0 to capital R, because where, from where to where the mass is present, 0 to capital R. So in this equation now, dw is what? Lambda dx gx by r. Lambda g by r gets eliminated. So this everything will become x square dx 0 to r. This will be x dx 0 to r. Anybody value of this? 2r by 3. Okay, I think now very good discussion. What is that? Where is the center of mass? R by 2. But where is the center of gravity? 2r by 3. Okay, fine. The definition what I said earlier. Center of mass, center of gravity will be different if size of object comparable to that of size of the earth. So I'll bring it, I think here only. So small diagram. Can be asked in advance. Though center of gravity is not there, but still very simple idea. It's not something very big, no? Center of mass, we used to show by star mark here. This is the center of mass. This is center of gravity. This is a rod. Huh? What is that green color? It's a rod. Oh, completed. Huh? Okay, now we'll take the general discussion. We'll make it some 20 minutes.